Hello.
Hello.
Hello. You see the desktop and everything seems okay? I got
Yes.
okay. I got my speakers on. Let me get the chat window up. Ah, Okay. Okay. I think I got everything up ready. Okay. So today, well, this week, we're going to continue. We're going to start going back to talk about methods. Okay. So we're going to be talking about these sections here. Okay. And we're going to also be talking about the what we talked about last week because we can take those for loop examples and turn them into methods. So we're going to do some examples with for loops that print out patterns, and then we also look at some turtle. We go back to writing some code that uses the turtle to draw pictures. Okay, so we can draw pictures with ASCII code characters with characters, or we can draw pictures with turtles. Okay, so first let's remind ourselves of what's really important about methods. Okay, what we want to talk about is, let me start Dr. Java. Started in this messed up mode again. So we close it and restart it. Okay, so the ideas we have, the most important idea is what we call procedure abstraction. Okay, and the word procedure, you could also think of this as method abstraction, procedure abstraction, function abstraction. The words that people use, some more or less as synonyms, are methods, procedures, and functions. Okay, so people use these words kind of interchangeably. To some people, a method is a little bit different than a procedure, which is a little bit different than function. But for most people, these three words are just synonyms for each other. Java likes to use the word methods. C++ programmers tend to use the word functions. So part of it is just that some languages prefer one word over the other. Okay, now procedure abstraction, or if you want, for us, method abstraction, that's one idea. Then method parameters. Okay, that's another idea. The flow of control, method return values. Okay, these are pretty much the ideas we have to talk about. Methods, method abstraction, method parameters, flow of control, and method return values. Those are the ideas that that we talked about earlier that we're going to talk about again. Now, in the reading, you see that parameters and return values are two of the actual sections. Flow of the control is mentioned, I think, in section 5. They're section 5.1. They don't, and method abstraction is kind of a more general idea. It's just why we even bother with methods. Okay, method abstraction is the idea of, like, why do we even have methods? Okay, and the idea is that when we keep repeating a block of code over and over again, we want to give that block of code a name instead of repeating it over and over again. Okay, so the idea is that if you see something that looks useful, you should give it a name, and then there might be parameters in the useful block, and those would be parameters to the method. Okay, so now a good example of that was some of our patterns. Okay, so let me download these puzzles and patterns. Okay, so let me So take up one of these puzzles. Okay. The puzzle was to print out a pattern that looked like that. Okay. But since that pattern could have and that pattern could have different sizes. For example, that would be the pattern with size 6. I can make this pattern have size 8. Here's what it would look like if it had size 8. Okay, so there's the pattern with size 8. Size 8. Okay, so and I could do it with size 9, or I could do a smaller pattern. I could do it with size 3. Size 3 would be easy to type. So notice that the pattern, it's the same pattern. You're going to start with the number 1, go up to the size. Then go down the line, start with a blank, then the number 2 up to the size. Then go down a line, blank, blank, start with the number 3 up to the size. Okay, so you might find that pattern useful. Okay, so we could put that pattern into a method and give that method a parameter that says what its size is. Okay, so then this is the code that really does the pattern. Okay, and all we've done is really wrap that code in a method so that we could reuse it. Instead of typing this code over and over again to get that pattern, that pattern, that pattern, we can just call the method. We can call the method with size 6, size 8, size 3. Okay, so we could call it several times and get these different outputs. And let's see, I can have to close that to compile this. Okay, compile it. Okay, and there's the there's the size 6, the size 8, and the size 3 output. And then there was another version of it. Okay, so this seems like a simple idea, but it's at the real heart of programming. If you've got code that you're going to be using over and over again for some reason, give it a name and try to find where there's parameters in the code that where you can say, but here's the input to the method that sets that parameter. Like if I didn't have this in a method, I would have to have this as a variable that would say what the size was. Okay, now notice that I could, if I just put a 10 there and a 10 there, now it's ignoring the size parameter. And that's what it would be like if you weren't putting it in a method. See, now they're all same. It's not really, it's ignoring the parameter, okay? And it's just using that fixed number, okay? A lot of times you start with code like this that's got some fixed number in it, and then you realize, oh, that number is the thing that I want to change. Okay, and that's what's tricky is to start with a block of code that might be used over and over again that you want to make it into a method, and you have to find the thing that is a parameter. Okay, find what's a parameter and then give it a name. At the same time, you give the block of code a name. Okay, this is what we mean by procedure abstraction. Finding a block of code that's going to be repeated, find where there's things in the block of code that can become parameters to the block of code, parts of the code that you'd want to change so the code does something not, it doesn't always do exactly the same thing, but does something similar depending on how you change that parameter. Okay, like an example here of another parameter I could give this, instead of, like right now, the triangle is printing out numbers. Well, something similar to this, instead of printing out numbers, would print out a character. Okay, so instead of printing out that number here, I could print the character. Now I have a slightly different method. It doesn't print this pattern. It just prints a triangle pattern, but a triangle pattern of different sizes. So now I can draw a size 6 with star, or I could draw a size 8 one with at signs, or I could draw a size 3 one with percent symbols. Okay. Whoops, what did I do? Oh. Okay. I've changed the idea. Now the pattern is to draw this triangle, and the parameters are what character to put into the pattern and how big the pattern should be. Okay. So I've changed the abstraction. I changed what this thing does. I gave it a different parameter. Now it doesn't print the numbers in the order I wanted them. Instead of printing numbers, it prints whatever character I put there. A hard thing would be, how could this thing sometimes do characters and sometimes do numbers? That's actually not very easy to do. Notice that I have it either printing out characters or I have it printing out numbers. That change, see, not all procedures, you have an idea, but not sometimes the idea is not easy to express in a procedure. For example, if I wanted this thing to sometimes print a character or sometimes print a number, it wouldn't be very easy or elegant to write it. I mean, I'd have to put like an if statement here that would just be kind of, it would be confusing to people. They wouldn't really know, why would you have a method that sometimes printed the numbers in these orders and sometimes printed stars? It wouldn't make for a nice method. It wouldn't make for a good idea, because it would be mixing two really different ideas, drawing these patterns with just a character versus writing these patterns with increasing numbers. Okay, so not every idea can be easily expressed as a method. Okay, now here we just had all these different patterns. Okay, and we could just make them into methods. Okay, let's look at some of the puzzle ones. I'm sorry, look at the pattern ones. Those were the puzzles. Let's look at the pattern ones. Same kind of thing. The pattern in this case was a lower triangle of a lower triangle of something. Like right now, it always prints stars. Okay, it takes size as a parameter. If you compile this and run it, okay, you get out, this is size 6. Okay, now again, I could, if I wanted to, oh, and this is written to, I wrote it a couple different ways. The reason there's a pattern A, a pattern B, and a pattern C is that they do the same thing, but there's more than one way to get that pattern. There's more than one way to get this pattern. Okay, so it's sometimes interesting to look at more than one way. Right now, I'm not interested in the more than one way, just talking about the idea of, well, let's write a method that draws the pattern. Then you could try to decide for yourself later if you think that one is better than this one, or maybe this one is better. Because anytime you can write a method, you can write it more than one way. And your real long-term goal is to be able to find a way that's easier for people to read. Okay. Like in this case, I don't really care that there's 3 of these, just want one of them. Okay. And I could change the size of the output. Okay. So the method lets me I can call the method as many times as I want with different size outputs. And then if I like this enough, I could say, but it'd be nice if why does this thing fixed as a star? See, I could look in here to find something that would be something I could change. Okay, so here I would say, well, why not let me change what's there? So I'll put a C and let that be a char C. So that's like we did before. And then now I could say, well, I'll print the $, or I'll print a star, or I'll print the letter P. Okay. Okay. All right. All right. So I've added a little bit more to the abstraction. Instead of it now, not just the size of the triangle, but what letter is put in it. Okay. So I added a little bit to the abstraction. Okay. If I look at pattern 2, I can do a little bit more with this one. So right now, it's just giving me different sizes. It's doing it 3 different ways. Right now, not so much interested in the 3 different ways. Okay, so it's just, okay, I could do size 6, size 8, size 3. Okay, so I can get different sizes. Okay, now I can look at the code and think, what else can be abstracted in this thing? What else could I, the pattern is this, but is there something that I could do a little bit more abstractly than that? So for example, we could change this to a character. Okay, so, but notice that this one, there's also what you print before that character. So why not put 2 characters, C1 and C2? If you make C1 a space, then it's doing the same thing as it was before. So if you make C1 a space and you make C2 a star, oops, I should use single quotes because they're chars, not double quotes. Since I'm making them chars, I need to use single quotes up there. Okay, so space star, it's doing the same thing as it was before. Okay, here I can do period and X's. And maybe here I can do star and @. Okay, so now I've got the same code. I just looked for something else that could be a parameter. I looked for something else that could be a parameter. And I said, oh, this code can be more versatile. I can get back, I can do exactly what it was doing before by putting space here and star here, by putting space in this parameter and star in this parameter. Or if we want now, I can do something more general. See, now I can get these different kinds of, there's the output like it was before, but now I could get ... X's, I can get stars and @. With size 3, you don't really see it very well. Make that size 12, and you'll get something that it's easier to see. Okay, so what do we do? We look at, as we write code, we look for blocks that we either think are useful, or we see that we're repeating. If we see that we're repeating a block of code, or if we think a block of code could be useful, we want to wrap it in a method. Okay, to take the block of code and put it in the method. But then you have to start thinking, where is there something in the code that doesn't have to stay fixed, or what is changing? If it's a block of code that's being repeated, what gets changed from one block to the other block? If it's not repeated exactly the same way every time, what gets changed, and make those parameters so that when you call the method, those that you get to choose what the values are for the parameters. Okay, so now let's talk about the flow of control. Let me take this one and put it in the Java visualizer. Okay. Okay, so let me put it in here in the Java visualizer. Okay, and let's just visualize a little bit of it. So I won't visualize too much. The visualizer may not even let us do all of these. The visualizer sometimes is picky about how much it'll let you do. Okay, now go ahead and visualize it. Okay, now the flow of control was this idea that you go from here, you're calling the method. Okay, so if we go back to the list of ideas that we were talking about, under the flow of control, you have method call. You call the method, okay? And the method executes, and then the method returns. Okay? So there's this idea of the flow of control. So over here in the visualizer, okay, right now we're at line 5, and we're calling that method. So when you call that method, you jump into the code, okay? And when you jump into the code, you pass the parameters, okay? So you call the method and you pass parameters. Okay. What does that mean? This 6 gets copied into that parameter. Okay, so this first value here in the method call gets put in the first parameter of the method definition. Okay, now notice that this thing here is a method definition. Okay, so that's another idea we can talk about. We have the idea of a method definition. Okay, the definition is where we tell people what the method does. Okay, whoops. Okay. Okay. The method definition is what tells people what the method does. Now, notice the method doesn't do anything until you call it. Yeah, if you put a bunch of code in a method, yeah, having all this code in front of me doesn't mean it ever does anything. If I never call it, it doesn't do anything. Okay, so it's real important to distinguish between the method definition and the method call. Okay, notice that main is nothing more than a method definition. And when you run your program, Java calls it for you. You don't call it, Java calls it for you. So what's in here gets executed. But if I don't call this, Java won't call it for me. So notice there's a big difference between these two methods. Public static void something, public static void, but this one's got a special name. So Java calls it for us. These don't get called unless we call them. So we have to have a method call to start the things going. Then when we have a method call, we pass the parameters. This gets put into there. This one gets put into there. And this one gets put into there. Okay. And the Java visualizer will show us that. Okay. So we're about to make the method call. Okay. We're at line 5, about to make the method call. When we go forward, we see that we get another idea. We get what's called the stack trace. Okay. Yeah. See, we've gone from line 5 into we've called the method. We're inside the method. So this is the flow of control. We've flowed from there to there. We've got these parameters, size, char1, char2. There they are. Okay. And we passed 6 into size, a space into char1, and a star into char2. Okay, so now this code starts running with these parameters, with these. Now these are sometimes called parameters, and these are called arguments. Okay, so another word we have, a couple more words we have, are method parameters, pass parameters to arguments. Well, actually, it's the other way around. We pass arguments to parameters. The arguments are in the method call, the parameters are in the method definition. Okay? Okay, so the method call has, so there's arguments, parameters. We pass the arguments to the parameters. Okay? Okay. So these are usually referred to as the arguments of the method call. These are the parameters of the method definition. When you make the method call, you pass these values to these parameters. Okay? Notice that I call these values because I'm going to put values into these variables. So method arguments are values. But they have to be specific strings, specific numbers, specific. Now, notice that here, let me change this code a little bit. Here's going to be a question. Am I passing a now remember I said I pass values. But now I put a variable there. So it looks like I'm passing a variable. In fact, there's a subtlety going on here. I'm not actually passing size. I'm passing size's value. So what happens here is that when you make this method call, Java goes to that variable and gets what's in it first. And then it goes to this variable and gets what's in it. And then it calls this method with the value 6, the value space, and the value star. See, here I explicitly put the value. Here I just gave a value a name. That doesn't change it. I'm not passing the variable. I'm passing the variable's value. So arguments are values. Okay, so over here, you have argument values. You pass the argument values to the parameters. And the parameters are variables. Okay, so the argument values are in the method call. The parameter variables are in the method definition. And you pass the arguments to the parameters. Okay. All right. Now notice we have a lot of words, and these words, I'm writing them out here because you do need to use these words. Like when you ask questions or when you talk to other people, you'll always talk to them about programming with these kinds of words. At least you should, because it makes a huge difference. So you should say when you make a method call, you say, well, the value of my first parameter was this. The value of my second parameter was this. The value I passed to my parameter. Okay. In this example, there's the value I passed to my parameter is actually 6. The value I passed to my parameter is actually space. Okay. Now, if I visualize this, okay. Now notice that I create a local variable called size, and a local variable called char1. So here's local variables in main, and now I make the procedure call, the method call. I make the call, and notice I get new variables. I get new variables up here, and I have old variables down here. The value of this variable got passed to that variable. The value of this variable got passed to that variable. Okay, and the value star got copied to that variable. Okay, and notice that I use the same name for size and size here. They're not the same variable. This size in here is not this size up here. Okay, you could kind of see that by suppose I do something really quirky down here. suppose I decide that whatever size somebody gives me, I'm going to increase it by 1 before I do anything. Okay, for some strange reason, I decide that whatever size somebody gives me, I'm going to make it 1 bigger than it is. So I'm going to always draw a triangle 1 bigger, or I'm going to draw a shape 1 bigger than what they asked for. Okay, all right, so watch why that shows me something. Okay, okay, there's size in main. Now make the jump into the method. Okay, now I have a size down here and a size up here. And it looks like, for all I know, they're the same size. Okay, they're the same variable. But now watch what happens here. I bump size up here to 7, didn't have any effect on this one. Notice that changing size down here, this variable is not this variable. They have what we call different scopes. Remember, we've talked about this before, like with for loops. When you declare a variable in a for loop, it lives inside the for loop. Well, this variable lives inside of these braces. That's what its scope is. This variable has the scope of that pair of braces. If it was inside of a for loop, the variable would be strictly inside the for loop. In this variable, it's inside the main method. This variable size, it's part of this method. Its scope is from that brace to that brace, from the beginning brace to the ending brace. So when I change size, I'm changing that one. But this one is not this one. They are different variables with the same name, but they have different existences. You can see that one exists over here, one exists over here. This over here is what we call the stack trace. That's another one of the ideas. Okay. Another one of the words we use, and it's also in the textbook. If you go to the reading assignment, wait for it to open. I don't know if it's their server that's slow or if my network at home is slow today. The Java Visualizer was responding pretty quickly. Okay. Let's see. Oh, I think it was that page. Yeah. See, flow of execution and stack diagrams. Okay. So flow of execution and stack diagrams are what we're showing over here in the Java Visualizer. Okay. So stack trace, I call this stack trace. Some people call it stack trace. Some people call it stack diagram. Okay. It shows you the stack trace or the stack diagram shows you a history of where you've been. We were in main, okay, and main had these variables. And then in line 8 of main, we called this method. When we called this method has its variables. We pass whatever parameters we want from here to there. You know, some of the parameters we passed were the values of variables. Some of the parameters we passed were just values that didn't have a name. Okay, so we pass things into these variables that are in the parameter. The variables in the parameter get initialized. The stack diagram shows us a history of that. Okay, and it shows us what line we're currently at in the method we're in. Notice that this method's colored differently than this one. This is the one that's suspended. We were in main. We stopped executing main to jump into the called method. We're in the called method now at line 18. Okay, we did line 17. Line 17 bumped up the value of this local variable. We tend to call these local variables because this variable is local to this one, while this one's local to that one. Okay. There are something called global variables, we'll talk about a little bit later, that belong to all the methods. You can have a variable that belongs to all the methods, but they're not as useful as people think they are. But there are local variables that belong to a method, like the parameters. And then there are also these global methods, the global variables that will belong to actually every method. Okay, so we call these ones local variables. Now, these local variables are called parameters. They're also called parameters. Okay, I could have local variables that aren't parameters. I could create new local variables down here if I wanted to. So I could have new local variables along with the parameter variables. Okay. Notice there's lots of words here. Yeah, there's lots of words, and I'm just trying to introduce the words so we keep thinking about them. Okay, now we watch the flow of control of a for loop. Okay, so we've been talking about the flow of control of a method. The flow of control of a method is that when you call the method, you take the value of that argument, the value of that argument, and the value of that argument, you put them into the parameters, and then you start executing the code. Okay. Now we're doing the flow of control of a for loop. The flow of control of a for loop, remember, is you do the initialization, then you do the test, then you do the body of the loop, then you do the increment, then you do the test. So, just step through that. So notice that these are, now here's examples of local variables that aren't parameters. Notice that this for loop created a local variable, and this for loop created a local variable. So now this method, this stack diagram, has got 3 local variables that are parameters and 2 local variables that are loop variables. So they're all 5 are called local variables, but they have different roles to play. These are parameters. They got their values in the method call. These local variables got their values by me declaring them. Okay. Notice that this is not the same kind of a declaration that this is. See, this declared a local variable and gave it a starting value. When you read this, you don't know what the value of size is. When you write this code, you just say int size. What's its value? Well, it depends on what somebody calls it. When somebody calls it later on, they'll give it different values. Okay, so notice the parameter variables get their values from the method call. The local variables get their value when you declare them. You give them an initial value. And then they change as the code goes along. So as I'm stepping through this code, I and j change values. So I and j change values as I step through this code. These can change value. Notice I changed size. You can change the values of these, but that will not have any effect on these variables up here. If you want to, in your method, you can change these things because they are variables. So you can change them if you want. Like here, I changed size by 1 just for the heck of it. So they are variables. They get their value in the method call, but then once they've been initialized in the method call, they can change. Just like this initializes the value in the declaration, and then the variable can change. So initialize in a declaration, initialize in a method call. Lots of different ideas. A variable has to get a value from somewhere. When the variable is a method argument, it gets its value from the method call. When a variable is a regular local variable, it gets its variable when you initialize it, when you declare it. Okay? Now, we keep stepping through our for loop. Eventually, the for loop is going to be over with. I have a lot of steps to go through. I want to get all through all of it. So I need to get I up to 7. Okay, now I got I up to 7. This is the last time through the loop. Okay, now I is 8. That's the one that's going to finally, the I is greater than the size. So this is the one that ends the for loop. So now I'm going to make this test, and it's going to be false. And now the visualizer shows me as I'm ready to leave the method. This is the part we call the method return. We're about to return from the method. When we return to where we came from, which was line 8 of main. So we're going to return to where we came from. Okay. Well, actually, line 8 of main was the last line of the code. So actually, I returned to the end of this program. Okay. Now, let me go ahead and put back a couple of these. And make this a small loop. Okay. And make this one kind of small also. Now let's do 2 method call. Let's do call, then another call. Okay. Okay. So we're in main. There are no variables yet because we haven't done anything. There's one variable. Okay. Int size equals 3. There's another variable. Char1 is a space. Now I'm going to call this method. I'm going to take the value of that guy and put it into that. Take the value of this variable and put it into that variable, and take this value and put it in there. Okay, so that's going to be the method call. The method call is going to transfer me from line 8 to line 17. And I'll get a new stack diagram over here because this stack diagram represents me in the main method. Now that's been pushed down, and the one on the top is always the current one. It's sometimes referred to as a stack. There's a stack of these because if this method called another method, then there would be another one up here. Okay, so you can get a stack of these things. All right, so this is the one that's active. We are in this one. This method called this method. We passed the parameters. The value of size got passed to size. The value of char1 got passed to C1, and the star value got passed to C2. Now, for whatever strange reason, I decided to increment size by 1 in this local size. Okay, so size is 4 now, had no effect on the size in main. Now I'm going to iterate through the for loop. So now I get a new local variable, I get another local variable, j. I'm going to iterate through the for loop. Okay. I'm about to be done. Okay, here I is 4. That's the last row. I'm doing the last row. Okay, now I'm going to hear I is going to become 5. I just incremented I to 5. It's going to fail this test. I'm done with the for loop. That means I'm done with this method. So now I'm about to do the return. Okay, now I'm going to do the return. When I do the return, this stack diagram goes away. This method is going to be done. All its local variables disappear. So we click, we're down here on line 30. We're going to go back to we're going to go back to line 8. See, we came from line 8, so we're going to go. Actually, we're going to go back to since line 8 is done. We're actually going to go back to line 9 because there's really nothing left to do on line 8. So we've actually now have completed line 8, so we're going to go to line 9. So now when I click forward, see, I'm about to return. The Java Visualizer actually shows you that you're about, it shows you this thing that you're about to return. We haven't talked about the return value yet. So our return value is not, we have nothing to return, but later on we'll see that there's a return value. Now we're about to go back to line 9. See, we came from line 8, but we're done with line 8, so we came back to line 9. Notice that that stack frame the stack diagram for this method is gone. Okay. Now do the print a blank line. Now make another method call. Now I have this value is going to get put into this variable. This value is going to be put into that variable, and this value is going to be put into that variable. So I'm making a new method call. Now I'm going to create a new stack frame, but in a way I'm getting all new variables size C1 and C2. These are new versions of those variables. Okay. Okay. So I did the method call with the method pass, the parameter passing. Now I can step through this just like before. And when I return from this one, almost done. Okay. There's I equals 6. That's the one that's going to see. Now I'm done. Now I'm going to return to line 30. Okay. I'm sorry, to line 10. See, I came from line 10. So I'm going to go back to it. But actually, 10 is done, and there's no more lines of code. So I'm actually finished. I'm going to return from 30. I'm actually going to jump down to 13 because there's nothing left to do after line 10. So now I'm about to return, and I return to 13. Okay, and 13 is the end of the program. So now the program is done. Okay. Okay. All right, so there is all these ideas. There's all these ideas. Okay, the flow of control, the method call, the argument, parameter passing, the stack trace, or the stack diagram, however you want to call it. Okay, okay. So we've shown these ideas over and over again, and we're gonna keep using. We're gonna use all these words. All the words that are in this list, we're gonna keep using them because they allow us to talk with each other. Let's just read the book. When the book uses this terminology, we use this terminology to explain what our code is doing. Okay. Now let's look at some same kind of ideas, but with the turtles. Because with turtles, you can do kind of interesting. You can draw some kind of interesting things with turtles. Okay. So we've been doing methods that printed output with characters. Now we can't, one of the disadvantages to the turtles is you can't use them in the Java visualizer. Okay. Now, so when we do the turtle stuff, we have to just use Dr. Java. We can't actually use the visualizer to watch what's going on. But up here on the website, there's a zip file with a couple examples of some couple of turtle examples. Okay, so here's a real simple example. Here's a method called square. Okay, it takes in a turtle. It's going to make the turtle do something, and it takes in a variable that's the size of the square. It wants to make the turtle draw a square. So what it's going to do is the turtle will turn 90 degrees to the right, step that much forward, turn 90 degrees, step that much forward, turn 90 degrees, step that much forward, turn 90 degrees, step that much forward. So that draws the four sides of a square. Okay, so that draws a square. All right, so then up here, I can use that method. I can create a world. I can create two turtles in the world. I put the one turtle, I make one turtle turn 45 degrees and go forward, then draw a square of size 100. And I make the other turtle turn 45 degrees in the other direction, step forward 200, and draw another square of size 100. Okay, if I compile this and run it, okay, so the turtle started here. One turtle turned 45 degrees, went forward, and then drew a square. The other turtle turned left 45 degrees, went forward, then drew a square. Okay. Now notice we don't see it happen. All the code just executes at once, and we don't have something that'll step through the code like the Java visualizer now. Okay. In fact, we actually do. Dr. Java, let's see if we can try it. Dr. Java has this thing called a debugger, which acts a lot like the Java visualizer. It's not as nice as the Java visualizer. Let's see if we can use it, okay? So we go into what's called debug mode, okay? Okay. And then, let's see if I can remember how to do this. We're supposed to get a button that we can press. I can't remember. Okay. What I have to do is see if I can remember how to do this. The debug, I should just check. I remember that there was a problem with the debugger. I had a problem with the debugger last year too. I thought it had been fixed. Oh, I think that's it. You need to do this thing called a breakpoint. See, toggle breakpoint. So I pick a line. I put my cursor on a line. Then I go up here and say toggle breakpoint on current line. Okay. Then should start the program. Okay. Now what's happened is it's like I'm in the visualizer and I've stopped at that line where I set a breakpoint. Now the visualizer does this for you in a sense automatically. You know, when you start a program in the Java visualizer, it always, what we say, breaks at the first line of the program. So over here in the Java visualizer, when I start the visualization, it automatically breaks at the very first line. So I'm at what we would call a break point. And then I can start stepping. I can step through my code. In the way Dr. Java works is you have to first set a breakpoint. Like I set it not at the first line, I set it at the second line. But now I can step, okay? Now I can do steps. I can step through my code, okay? So now I can say, let's see, here you can, I don't know if we can see, like scrunch this over a little bit. Here's the window. Notice there's no turtle over here yet because I haven't created any turtles. I did create a world. So line 6 already got executed. That created this world. But then I had the debugger, what we call the debugger, which is like the visualizer. I had it stop on line 7. Then I'm going to do step, and I get that turtle. And then I'm going to do, now I'm at line 8. See, line 7 is red because that's where my breakpoint was. So that's the line that the program halted at. Line 8 is blue. That's like the yellow over here. The yellow is what you're about to execute. So I'm about to create another turtle. Okay, now there's actually 2 turtles sitting there. Okay, now I'm about to have one of the turtles turn to its right. Okay, you saw the green turtle turn to his right. Now the green turtle is going to move forward. Now the green turtle is going to square. Now, square is a method. So here's 2 ways of thinking about it. I could at this point say, just do the method as if it was a single line of code. Notice that when I did this, it did it as if it was a single line of code. But that's actually a method that somebody else wrote. At this point, I could either just tell Dr. Java to do that method, or I could tell Dr. Java to let me watch that method, like the Java visualizers. Now, the Java visualizer, you don't have any choice. When I call a method, the Java visualizer always goes into the method. Okay, the Java visualizer always goes into the method. Dr. Java actually gives me a choice. Like right now, I'm going to do what's called step over. When I say step over, I'm saying just do the square. Don't step into it. That's step into. Just step over it. So that's going to draw a square. Okay, there's the square. Notice that that just happened in one click. Okay, now I'm going to tell the other turtle to turn left. I'm going to tell the other turtle to move forward. Now I'm going to step into square. I want to watch square happen just like I watched the methods happen in the Java visualizer. When I stepped into something in the Java visualizer, well, in Java visualizer, I don't have any choice. I always step into a method. Okay. Here, I can step into square. Okay, so I'm going to step into, and then I did the parameter passing. Okay. Now, the Java visualizer does a great job of showing you the parameter passing automatically. When you jump from here to here, you get a stack diagram. The Dr. Java doesn't do that automatically. I don't automatically get a stack diagram. To get a stack diagram, I have to work kind of hard down here. Okay, so I have to create it myself. So for example, I create a variable t, and I create a variable size. Okay, there's my stack diagram. I have to type the variable names over here myself to see that size got 100. And the turtle variable is actually pointing at this turtle over here, but that's kind of hard. How do you say that T is pointing at this turtle over here? So they don't show you that very well over here. If I had given that turtle a name, I would see the name of the turtle here. I can give a turtle a name that's not the same thing as its variable. Like the turtle is not named T2. I could give the turtle a name like Bob or Jim or Jane, and then I would see the name of the turtle down here. Okay. It does not draw nice diagrams like this does. The Java visualizer draws way better stack diagrams than Dr. Java does. And in the case of the Java visualizer, it shows you the objects over here. It draws you the arrows to the objects. Like here, we didn't use any objects, but it shows you the variables. It would show you the objects. It would show you the arrows to the objects. The debugger in Dr. Java is not anywhere near as nice as the Java visualizer. It lets you watch code happen, but you have to do a lot more work. Okay, like for example, you don't get an automatic stack diagram. You have to kind of build one over here, and then the stack diagram is not as easy to read quite. Okay, now here I'm going to do a turn right. Okay, so turn right, go forward, turn right, go forward. Now I'm drawing the square. Okay, now notice I'm at the end of the method. So now I'm about to see the return. This method is about to return. Notice that this does exactly the same thing that the Java visualizer does. When you're about to return from a method, it highlights the closing brace. It highlights the closing brace to give you a sense that you're about to return. So when we get to, I have to do a lot of clicks over here. Okay, see, I'm highlighting the closing brace because I'm about to return. So notice that that's common. Highlight the closing brace to mean you're about to return. Highlight the closing brace to mean that you're about to return. Now I know where I'm returning to. I'm returning to line 14. Notice that the Java visualizer shows you where you're returning to. You're returning to line 8. When this guy returns, you'll return to line 8 in main. But we don't have these nice stack diagrams over here. Okay, it's not so obvious where, now see, here's the stack. Now, it is actually, it's right here. I'm at line 14. You have to read it carefully. I'm at line 28 in square. And here's where I'm going to return to. I'm going to return to line 14 in square. See, I'm going to return to line 14. So that part of this part of the stack diagram here, that you are at line 30 and you're about to go back to line 8, it's also there in Dr. Java, but it's in this little window. And this window is different than the window that holds the variables. Okay, notice that this window holds the variables and tells you where you are. This little box holds the variables and tells you where you are. Over here, this window tells you where you are and where you came from. You are at line 28, you came from line 14. This window over here holds the variables, and you have to put them there. It doesn't even hold the variables automatically. You have to put whatever variables you want into that window. Okay, you have to watch a specific variable. So they call this the watch window. The Java visualizer watches every variable automatically. That's one of the beauty of it. It just automatically watches every variable. Dr. Java, you have to tell it what variables you want watched. Okay, now I step again and I will return. Okay, now I returned to the last line here. Notice that, don't get confused by this. This line is highlighted because that's the break point. I returned to this thing, which if I step again, my program is done. Okay, my program is actually done. See, I can't step anymore. See, there's nothing highlighted anymore. Okay, so Dr. Java can kind of mimic much of what the Java visualizer can do, but it's just much harder. Well, not much harder. It's a little bit trickier to use. Okay. All right. Now, let me show you one quirky thing about this. Let me restart it. Okay, I've got my, now I'm going to erase this breakpoint. And I'm going to put a breakpoint at line 6 because I kind of skipped over line 6. So I'm going to put a breakpoint at line 6. Now I'm going to start the program, run. Okay. Now I haven't created a world yet. Okay. So when I step over, I'm going to say create the world. And where did the world go? There. Oh, it took a little while for it to pop up. It took a couple, I thought the world was going to appear instantaneously. It took actually a second or two for the world to pop up. Okay, so that created a world. Now I'm going to say, okay, now step over to create the turtle. Now, now somebody wrote this turtle code. It's not our code, but what if you say step into, like we stepped into our square? Well, actually, if you say step into, what happened? It should have stepped into the turtle code. I don't know what happened. Oh, I thought I put the source. Oh, you can't step into the, yeah, you cannot step into the world. Okay, I can probably change that later on, but I didn't put the source code. I have it. I put the library code in Dr. Java, but I didn't put the source code. So if you want to, if I gave you the source code to the turtle library, you could actually step into the turtle code. Yeah, before, let me restart this. Okay. Oops. Oh, I need to put it in debug. Oh, you have to put it in debug mode first. Okay. Put in debug mode, then say run. Okay. Now I can't step into the turtle library because yeah, I could probably give you that code and you could actually, but you wouldn't know how to read it very well anyway. But what's more interesting is, oh, no, I clicked step into and I shouldn't have. Okay, let me reset it again. Whoop. Yeah, let me reset it again. Oh, it's hung. Something. Dr. Java got hung now. Now it's not responding. So let me just kill Dr. Java. Oh, notice I can't even kill Dr. Java now. This kind of stuff happens a lot with software. You know, once you become starting to work with software more diligently, you start getting, you know, we're working with software in a pretty sophisticated way, and Dr. Java got messed up. I clicked on a button I shouldn't have clicked on, and now Dr. Java is stuck. So I could try closing it there. Okay. Okay. Windows has a tool for things like this. You know, right now, notice that Dr. Java won't quit. You see, these menu items, you know, none of these are working. I can move the window around. Look, see, when I resize it, it doesn't refresh itself. Dr. Java is really messed up. See, it won't refresh this window anymore, and it's not responding to closing it. Let me try this one. No, that one didn't work either. Okay, so Windows has something called the Task Manager. If you go over here and you type Task Manager, you get this program called the Task Manager. And this is a program that lets you kill programs that are running. Okay. In our case, we want to kill Dr. Java. Okay. And you have to find it. See if I can find Dr. Java in here. Yeah. Okay, go under details. This is why computers take years to learn if things are confusing. I was running Dr. Java over here, but Dr. Java isn't a program from Windows point of view. From Windows point of view, Dr. Java is a Java program, so it doesn't show up as see, Dr. Java doesn't show up anywhere here. This is Dr. Java. You can see it here. I called Dr. Java. This is when I ran Dr. Java here. So you notice I know that's Dr. Java because I can see that that's when I started Dr. Java. That was the command, what we call the command line that started Dr. Java. That was when I double clicked on this. That was because I double clicked on this batch file here. But Dr. Java isn't a program from a Windows point of view. The program is Java. So I need to end that task there. So I end that task, see, and Dr. Java is gone now. Pretty weird. Yeah. So Dr. Java got hung up somehow, and to close it, I had to close the Java the Java program that was running Dr. Java. Dr. Java is a Java program, and it runs in what's called the Java virtual machine. Okay, so let me restart Dr. Java again. Okay, see, now Dr. Java is okay, and I could load my Square class back into it. Okay. Now, remember, we're almost done. Let's see. We got, what, couple more minutes? Couple more minutes. So if you want to use Dr. Java, kind of like the Java visualizer, you have to go into debug mode. You have to pick a line of your program, toggle the breakpoint at that line, start the program. Okay, now the program's running. Now I can start stepping through the program. If you're at something that you didn't write, you use step over. If you want to step into something you wrote, you use step into. So here I use step over, and I should see the world show up there. Okay, took a couple seconds for the world to show up. Okay, then now I'm going to create a turtle, but I use step over to create the turtle, step over to create another turtle, step over to make the turtle turn right, step over to make the turtle go forward. But now I get to my code, square. I want to watch my code, so now I use step into. Now I jumped now from line 11 to line 20. And then over here, here's the stack trace. I went from mains line 11 into squares line 20. Notice that the visualizer in Dr. Java is nowhere near as nice as the one that's in the Java visualizer. That's why I waited this long to show you Dr. Java's ability to visualize code. We've been using the Java visualizer a lot because it's way easier to use. The Java visualizer is just, actually very elegant and very well designed compared to Dr. Java. Now, Dr. Java can actually do things that the Java visualizer can't do, but we don't really need them at this point. For us right now, we mostly want to just see the code, how it works. And we can pretty much kind of see how it works with the Java visualizer, with Dr. Java, but the Java visualizer makes it much easier. And then here I just say step over and I watch the turtle draw the square. Okay, all right, so we've reached the end of the time. Okay, so what we're going to do is on Wednesday, we'll do more examples of this. We're going to look at more examples of these ideas. Oh, where's my desktop? Oh. Dr. Java's hung up again. Okay, we're going to do more examples of ideas with all the terminology, all the words that we were using. We want to look at more examples of these different, oh, that's the wrong one. We want to keep, we want to emphasize all these terminology. Just keep doing examples where we practice using these terms. So we'll look at more and more examples and talk about what are parameters, what's a method definition, what's a method call, what's the flow of control, what do we mean by, make sure we understand arguments and parameters and what it means to pass arguments to parameters. Just get practice, look at more and more examples and just get practice using these ideas. Okay, so we'll go ahead and quit there. And if you have questions, send me an email. Look at these examples. There's a couple more turtle examples in that folder that I downloaded from. There was like 3 or 4 simple turtle examples that are kind of cute that you can just trace. Practice trying to trace them with Dr. Java. Try practicing using the debugger to trace them, and you'll see that it's nowhere near as nice as the Java visualizer. But once you get used to it, it can help you find mistakes. It's actually called a debugger because it's supposed to help you find mistakes in your program. Okay, so I'll go ahead and quit now. Oh, somebody asked about assignment 4. It hasn't been posted yet. I'm still working on writing assignment 4. So assignment 4 hopefully will be up there pretty soon. I'm working on grading the exam and creating the homework assignment. And right now, each one of them is keeping the other one from getting done. I'm working on both of them, and it's taking a while to get both done. Okay, so but if you have questions about the methods, please let me know if you have any questions. So turn off the sharing. So we'll meet again on Wednesday. See you then.
See ya.